everyone, I'm Castleberry. Welcome to another one of my philosophical lecture shorts. Today we're going to continue my course in logic. Our last video was dealing with chapter 5.1 of Hurley's A Concise Introduction to Logic. Today we are going to discuss chapter 5.2, where we take our discussion of categorical syllogisms and start using Venn diagrams to check for validity. So one thing I didn't do in the last video that I want to do real quick, because we'll need it today, is I forgot to do at the end of the first section on showing how we went from taking an argument like down here, some M are not P, a categorical syllogism, excuse me, some S are M, some S are not P, and taking it and putting it into in its mood and figure this way, where OI, O1, we went from here to here. What we didn't do at the end of that video was go from the mood and figure to the argument. So I want to do this example that we'll come to in a second, just to show you how we can do that. You probably already figured out if you've read in the textbook, but if you were to take, let's see, I'll draw it from this way. So if we were given an argument, we were just given this, so EAE2, so we're given the mood and figure of the argument, we can go easily from here to what the argument should look like. So remember, the first premise is always the first letter, which is E, so that's going to be a no blank or blank. So now 2 is going to give away where the middle term is and where the rest of the terms are. But for those who don't know, let's see, I'm going to have to actually draw this way. So the first one would be, I'll turn it around in a second. So no, we'll have blank, or blank for those of you who want to do the figure last. Then we have A next, so that we know is an all blank or blank, right? So all blank or blank. And then we'll have the conclusion here coming up, which is another E. So then, well, this one we always know, because remember the conclusion, we always know where the major and minor term are. We have no S or P. Remember, the P, the predicate, is always going to be the major term. The S is always going to be the minor term. Now, you have the 2 here. You have the figure. That's the position of the middle term. And so if you remember the tight shirt collar, 1 went down like this, then over. 2 is like this. Okay, so we have the M's are going to be here on that side. And then we always know the major term goes there, and the minor term goes there in the second premise. So then from that mood and figure, we get no P or M, all S are M, and no S or P. Okay, so practice that. It's in chapter 5.1, but we need it for all the chapters to come, and today we'll need it. All right, so back to today. Using Venn diagrams to check the validity on categorical syllogisms. Couple things to keep in mind here. Venn diagrams for this will require 3 overlapping circles that we'll use to prove validity. And the chapter 4, we had 2. We're going to add a 3rd one here, which is going to allow us to check both premises here. And a couple rules to keep in mind when we're doing, actually let me show you this before we get to the rules. Here is what a categorical syllogism as a Venn diagram looks like. We've numbered out the little sections here, 1, 2, 3, 4, 5, 6, 7. We have 7 places where there could be marks. What I will do when I get an argument, I just immediately draw the 3 circles, S, P, and M, and then we get to work. So what are some things to keep in mind when using it to check validity? A couple rules here. First, marks are only entered for the premises. So you're not going to enter marks for the conclusion. The conclusion is going to be used to check if the information in the conclusion is proven by the premises. Always, if there is a universal in a particular premise, like one universal, one particular, always do the universal first. If they're both universal, it doesn't matter, but it will help you to do universal first. 3, this is one that I tell a lot of my students. It's concentrate just on the 2 circles you're talking about. For example, here we say no P or M. In a second, we're going to look. Imagine that the S circle doesn't exist and there's just P or M. Now, once things start to get marked in there, you might have to pay attention where this other one is, but for the most part, just try to concentrate on the 2 you're discussing. We'll have an example here today that shows where you kind of have to look at the other one too. Let's see what else. Oh, remember when we get to I and O propositions, some S are P, that's the same thing as saying there's at least one S that exists, and that S is a P. All right, and when you have some S are not P, what that means, there at least is an S that exists, and that S isn't a P. Definitely isn't one. All right, remember that's how we can translate it. Another thing to keep in mind, shade all areas in question. Make sure you do that. And X can be divided on a line, so we can find maybe an X like right here. All right, X, I'll just draw, I'll erase it in a second. You can find an X can be on a line, but X can also be in the middle of something here. But the one thing we don't want, all right, and I'll show you how we'll determine that in a second, all right, depending on what shade it. Just keep, so it can be both. depending on what shade it, and just make sure there's no X's that are outside the circles and none that come in intersections of two lines, okay? That's never going to happen. All right, so let's show you how we do this. I have a few examples up here. We're going to start with the Boolean school, because remember, if we can prove something is valid from the Boolean school of the Boolean standpoint, it's going to be valid for Aristotle's standpoint. And then if there's ones that turn out invalid, that we'll see that have a universal premise and a particular conclusion, then we'll go and check for Aristotle. I'll show you those in just a little bit that has universal premises with a particular conclusion. Excuse me. All right, so let's start with bool. Let's look at the example. We've already filled it in. We have no P or M, all S or M, therefore no S or P. We'll put our little dot there. We'll throw that down. Okay, let's see how we would fill this in. So first we'll start, since both are universal, that's one of our rules. It doesn't matter which one we start with. We'll do no P or M. So try to ignore the S and just imagine, if I could turn it up like that, we're looking at just P and M this way, just like we draw a normal diagram in chapter 4. So we'll go no P or M. So that means there are no P's that exist that are M's. So if you remember, you would color in this area here. Now, even though the S is coming in here, you have to color in the entire area that P has to deal with being an M, okay? That all goes this color. That's why you kind of avoid the S. Just imagine it's not there. You color in exactly what would have been colored if it was just P or M, which would be that middle. So it says no P or M. All right, so there is no P's that exist that are an M. Then we have all S or M. So now we're just looking at S and M. Ignore the P. So what all S or M means is that there are no S's that exist that are outside of M. So that is all this area here, and it would include that area there, okay? Area that's left that's open is this one right there, okay? And then we ask ourselves, now what we need to do, now that we have these premises filled in, we see, is the information these two premises gave in here, is that what the conclusion is looking for? So we have no SRP, so now we're looking at S, and we're looking at P, and we have to say that there are no S's that are P's. So that would mean this little middle part, which you can't really see anymore, would have to be completely all filled in where the S touches the P. And if we look, I'll circle it right there, it is. That would be, what, 6 and 3 here on this. It's all filled in. And so that's the information we'd have. And since that's what the conclusion says, that's what our premises give us, we have a valid argument. See, easy enough.